Okay, so let us talk about the micrometer screw gauge. That's the diagram of a micrometer screw gauge. So I'll talk about the main parts. You have the main scale. This is the main scale. And then you have what we call the datum line. That's the datum line. Or the center line, sometimes called the index line. But this name is not regularly used. It's often known as the datum line. And then you have the thimble, I like calling this the secular scale. Right? And then you have the ratchet. I will talk about the ratchet in a moment. But first of all, I want to talk about the accuracy of the micrometer screw gauge. This thing has an accuracy of 0.1 millimeters. I don't think you will see it in centimeters because most of the times it's calibrated in millimeters. So the accuracy is 0.01 millimeters. And this instrument is used for measuring very small objects. And I mean like really tiny objects. For example, the thickness of a wire. If you want to measure the thickness of a wire, you want to use the micrometer screw gauge. As you can see, it's very accurate, 0.01 millimeters. That's insane. Right, so you have the ratchet. Let's talk about the ratchet. The ratchet is also known as the friction flash. That's the ratchet, the friction flash. I think both of these names are fitting. First of all, because ratchet, this thing makes a ratchet sound. And then friction flash. Well, the purpose of this thing is to sort of limit the friction force applied to the object that is being measured. It sort of prevents over tightening. It prevents over tightening. Right, the ratchet or the friction flash. Now let's talk about taking a reading from this thing. We want a reading, so what we do? To get the final reading, the length of an object, we are going to add the main scale reading to the secular scale coincidence. I'll explain the secular scale coincidence multiplied by the accuracy. I've just told you that the accuracy is 0.01 millimeters, right? So let's look at this diagram. So you have your datum line here, the center line, right? And then this is the main scale. So to obtain the main scale reading, what we basically do is to locate the number that's just on the immediate left of the secular scale. This is the secular scale. So you look for the division that's just on the immediate left of this secular scale. So that's 2 millimeters in our case. That's 2.0 millimeters being the main scale reading, right? This is the main scale reading. Let me change the color. This is the main scale reading. And then the secular scale coincidence. To obtain this, you look for the mark that coincides with the datum line. So the reading on the secular scale that coincides with the datum line is 31. This is 30, so this must be 31. So the secular scale coincidence is the 31st mark. That's 31. And then we know that the accuracy of this thing is 0.01 millimeters. So that's, you multiply that, you have 0.31 millimeters. And that's the reading, 2.31 millimeters. And that's very small. You can't obtain that reading using a ruler. That's why we have to look for instruments that are more precise, like the micrometer screw gauge. Right. 2.31 millimeters. Now let's do the last example. So this is a bit different in the sense that the main scale reading, so to get our length, we said we add the main scale reading plus the circular scale coincidence times the accuracy, right? Now, notice that the main scale reading is no longer this long bar. So you have this shorter bar, which is 0.5 millimeters. So this is an additional 0.5 millimeters. So now the reading we're going to have here is 14.5 millimeters. That's the main scale reading. And then we add that to the circular scale coincidence, the mark on the circular scale that coincides to the datum line. Remember that this is the datum line. So what's that mark? This is 45, 46, that's 47, because we are going to 0, right? 45, 46, 47. So 47, the accuracy is 0.01 millimeters. And then we clean that up, we have 47 times 0.01 is 0.47 millimeters, right? So you add that 14.5 plus 0.47 is 14.97 millimeters. And there you have it. That's how you use the micrometer screw gauge to measure very small lengths. Until we meet again next time, get love boy and stay winning.